Welcome to the course of PWE. Today we are going to study Ohm's law. Ohm's law, before studying Ohm's law, you have to know three terms, basic terms, which you are going to use it in the entire BWE, that is voltage, current and resistance. Now starting with voltage, what is the voltage? Voltage is the potential difference between 2 points. Now what is this potential? By definition it is called that work done to bring a unit charge from infinity to a particular point. But what is the meaning of that? Where is that infinity? From where we are going to bring something? Actually, in simple terms, the meaning of this definition is potential means potential of a particular point or a body is the energy required to create that object in the universe. That is called as the potential of that body. Hence, there is no such instrument as such till now which measures the potential of certain body. Each and every particle or object or matter in this universe has its own potential, but there is no instrument which can measure that potential. But there are instruments which can measure the potential difference between two objects that are called as voltmeter, and this potential difference is called as voltage that is measured. Now you are clear with the term that potential difference is voltage, and that is the difference in potential between two objects. Now what is potential energy of energy required to create that object in the universe? Now I will show you some two situations. I will consider a bowl filled with water. I am keeping it at the height h from ground. Suppose this is height h. Now the bowl is containing water, but it is not moving. Water is not moving, it is stable. Why so? Why the water is stable? Water is stable because suppose water has number of particles are there in water. Each and every particle of water is at the same level from ground. Hence, its potential energy is mgh. Potential level energy of each particle is same. It's not different. Hence, therefore, there is no particle is interchanging its energy because each and every particle is having the same energy. But now, if I am tilting this bowl, I am tilting this bowl. When I tilt this bowl, water starts falling. Why the water is falling? The water starts falling because there is energy difference between two particles, any two particles of water. Here the energy of the particle is mgh1 and energy of this particle is mgh2. Hence there is a height difference. Hence, as per the nature of particles try to reach at the lowest energy state if they are having higher energy. Now particle over here sees that the particle next to it has a lower energy. So what he will do? He will release his energy. He will try to give his energy and come to the lowest position. So the particles all, if they get a chance, they try to go at the lowest position. Now, how will they get the lowest energy? By going at the lowest height. Therefore, they at the lowest state, if it is possible. And therefore, the water starts spilling over. It tries to go down. Here, there is no chance of going down. Therefore, the water is a stable state. What we understand from this, that if there is an energy difference, there is flow of water. If there is no energy difference, there is no flow of water. In similar terms, I will be explaining the terms of voltage, and then there will be newcomer in our story, that is current. Now till here we will sum up that if there is no height difference or energy difference, the water is stable, it will not flow. And if or flow of water is zero when there is no energy difference. If there is energy difference, then there is flow of water. Similarly, I will consider here a circuit or a wire. Just a wire. In a wire, metal wire, there are number of electrons filled. Infinite number of electrons are there in a conductor or a wire. We will be considering here. Now, if the electrons of each and every, if the energy of each and every electrons is same in this metal wire, will any electron give an energy to each other? No, because each and every electron is having same energy. Therefore, there will be no flow of electrons, as there is no energy difference between two electrons. Energy of each and every electrons is same. Therefore, there will be no flow of electrons. Now, or we can say that the potential, here there was gravitational potential. Now, in our BWE, the potential we mean by electrical potential. We mean here the electrons are constant, they are not flowing. What it means, that the electrical potential of this electron and this electrons is the same. Here the water is not flowing, that is the gravitational potential of two particles is the same. Here current electrons are not flowing, therefore the electrical potential is same. Here is same. Here gravitational potential is same. Here there is no flow, therefore no flow of electrons. I will denote by E minus because they have actually negative charge. Therefore no flow of water. Now just remember this point and we will go further. The second case of in electrical or electronics. Now if the conductor or conductive wire that is filled with electrons, if I apply, there are a lot of electrons actually, but if I apply some extra energy to this with respect to this electron, the electron over here, with respect to electron over here, if I apply an extra energy to this electron, what will happen? That this energy, it will try to go to the lowest possible energy. It will see that, alright, I am having 10 coulombs of energy, 10 units of energy. He is having 2 units. I will transfer my 8 units to him. I will try. When this electron gets the energy, it will again try to be at the lowest energy state. It will give the energy to this electrons, and hence as we give energy with respect to the stable electron or least electrons at the least lowest level, that is, we are giving energy to some electrons, then what is happening? That electrons start flowing, or they pass on the energy to each other. Due to energy they start flowing. Hence, what is happening? That flow of electrons takes place. When we apply energy, when there is a voltage, as earlier there was no difference. We wanted to make electrons flow. Therefore, we applied a voltage or potential difference or energy difference. We created an energy difference between this level and this level. Hence, the electrons here became more energetic and they passed on the energy. Hence, there is flow of electrons due to when we give energy or when we create energy difference. Here, we are creating here energy difference means what we are doing? We are creating electrical potential difference. And due to this electrical potential difference, electrons are flowing. Here we created gravitational potential difference by tilting the plate. And our water started flowing, or molecules of water started flowing. Here electrons are flowing. Are you getting the difference? That if we apply energy difference or electrical potential difference, electrons start to flow. If we apply gravitational potential difference, then water elements, physical elements start to flow. Comparing this physical topology with our electrical topology, this potential difference is nothing but voltage. You can say voltage as the electrical pressure and electrons. Now, a newcomer is coming in our picture, that is current. Current is now, as I said, when we apply voltage, there is a flow of electrons because they have to flow as they are energetic now. As they are energetic, there should be some measurement of their flow. To measure that flow, a new term called as current, I, came into picture. I. What is I? Number of charges that are flowing from a particular area per unit time. If we take a snapshot of number of electrons flowing through this cross section, then we will get in 1 second. Then or we record the number of electrons flowing per this slot in 1 second. Then the value we will get, if 10 electrons are flowing in 1 second, then the value of current is 10 amperes, and the unit of this current is amperes. It is measured in amperes, and that is basic definition of current is the rate of flow of electrons per unit time, or flow of electrons per unit time. The rate is obviously per unit time. Basic definition of current is flow of electrons per unit time. So this is flow of electrons. Hence, by knowing and understanding this, we have just understood what is voltage. Voltage is the potential difference, and what is its relation with current. Current is the rate of flow of electrons. And now we will know third partner of these two, that is voltage and current. New partner of voltage and current, that is resistance, that will be coming into picture. Now suppose we will consider a wire which has been given a potential difference V. So the electrons in this wire present in this wire, as this is a conductor, it is a conductive wire, we will assume. As it is a conductive wire, there will be many freely available electrons in it. So there are a number of electrons are there, and if I apply a potential difference between these two points, therefore the electrons will start flowing in a particular direction. If we apply positive potential over here and negative over here, then from positive to negative, always the charges always the electrons will be flowing from negative to positive, always. As unlike charges attract each other and like charges repel each other, in the same manner here that repulsion takes place, and hence actual pressure is created over here. The electrons are repelled, and actually the assumption is like this. Thus electrons are repelled, negative charge repels this electrons, and this electron comes closer and closer to this with a force, but there is again like charges repel each other, and this electrons again goes toward this, but again there is also a repulsive force between the electrons. We can say it is assumed that there is a spring-like structure between two electrons. If this repels this, again second electrons. You can imagine this, the flow of electrons in this way, that this repulsion transfers from electron to electron. Now the electron starts flowing as we apply electrical potential difference. Now potential difference is applied between point X and Y. So each and every material has its own properties in nature. So even this conductive material of XYZ metal must be having some properties. So there are some obstructions to these electrons, opposition to this electron and their path, such that due to these obstructions present, these obstructions are actually material dependent. The many electrons collide to these obstructions, and hence the speed or the flow of electrons decreases. You can say current as a speed of electrons. The speed of electron decreases, therefore the current decreases due to these obstructions. These obstructions are material. These obstructions vary material to material. But if now, just imagine if the cross section, that is, we can say, suppose this obstruction, this property of material, if we denote this property by rho, it is denoted by rho. This property of material that opposes the flow of electrons is called as rho. Is called resistivity. RESISTIVITY. This property of material which opposes the flow of electron is called resistivity. Resistivity, due to resistivity, the speed of electron decreases, that is, current decreases. Hence, it varies material to material. Now, if I change the cross section of this wire, I make this wire thick, or the thickness of wire, then what will happen? Now, due to increase in cross section, the number of there are more free spaces available for the electrons. If it is going from here, it collides over here, it can go from here. Now, as compared to earlier case, there is more free space available for the electrons to move. Therefore, the speed which was decreased earlier as the thickness was less, now the thickness is more. As compared to earlier, the opposition to the electrons have decreased. Hence, we can say, we will now denote this opposition. Suppose we will just summarize it. Opposition to flow of electrons is proportional to resistivity. As resistivity increases, the opposition will increase. It's also proportional to what? It is proportional or inversely proportional. As the cross section increases, current will increase and hence the opposition will decrease. As cross section, if we denote this cross section area by A, as the cross section area increases, opposition decreases. Hence, inversely proportional to A, cross sectional area. But again, if the length of the material, if the length of this material is more, again wide, then obviously as the electrons have to travel a lot, their energy ultimately decreases. Hence their speed decreases, because when the energy of a person decreases, he runs very slow. So as the length of the wire increases, again the flow or speed of the electrons decreases. What is speed of electrons? That is current. Current will decrease. Hence current opposition. But what? Opposition of flow of electrons increases. Means what? Opposition to flow of electrons is directly proportional to length of the wire. Hence, this opposition is called as resistance of the wire, and it is given by R. Resistance. As we know, now we have deducted these 3 points. Analyzed these 3 points. Rho, that is R, directly proportional to resistivity, R, inversely proportional to area, or R, directly proportional to length. Combined formula of R is equal to rho L by E. In some books, it is also written that R is directly proportional to L, inversely proportional to area, and they write directly as this way: R directly proportional to L by A. To remove this proportionality sign, they put R is equal to rho L by A, where rho is the resistivity of the material. In both the concepts, it is the same, that this formula is reduced at the end. The meaning of it is same. Thank you. Now, we will be considering, we have seen Now, till here we have seen 3 quantities, that is voltage, which is a potential difference between 2 points, or electrical pressure or electrical potential difference. It is the unit of voltage is volts. And the symbol is V. Current that is charge per unit time. Charge per unit time. Speed of electrons. Charge is electrons. Negative charge. That is it is denoted by, it is measured in amps, amperes, and denoted by letter I, or its symbol is I. Third quantity which we saw is resistance. Resistance is measured in ohms. And the symbol for resistance is R. And resistance symbol for resistance is R, and unit, the unit of volts is V. Unit of voltage is V, unit of current is amperes, and the resistance is ohms. So it is again denoted by V, A, ampere, short form, and ohm. There's this symbol for ohm. So these are these three quantities are there. What is this Ohm's law? Actually, Ohm's law tells the relation between V, I and R. Between these three friends, it tells the relation. What is their relation? Either they are brothers, sisters, they are father, mother, or son, or anything. What is the relation between them? It's specified by Ohm's law. What is that relation? Now let's see. Now we will consider the Ohm's law, very famous Ohm's law. Ohm's law basically states the relation between voltage, current, voltage V, current I, and resistance R. Now what it says is, if we apply voltage V between the open terminals of a resistor, if we apply voltage V between the two terminals of a resistor R, whose resistance is R, then the current of value I equal to V by R will flow through it. This is the basic current, so Ohm's law. It says only that the current flowing through a resistor, when any voltage V is applied across it, is equal to the voltage applied divided by the resistance of that particular resistor. Now this is I is equal to V by R, or V is equal to IR, is the main and basic and only the statement of Ohm's law. And an important thing to note about this is, it is temperature dependent. This law is only true for a fixed temperature. If the temperature changes, then the parameters will change. This law is set for fixed or constant temperature. So to remember, for remembering point of view, this is Ohm's triangle V, IR. Remember in this way. If we know voltage and current, then we can find the resistance R is equal to V by I. If we know current and resistor, then we can find the voltage, that is equal to IR. If we know voltage and resistance. If you don't know current, then we can find it by I is equal to V by R. This is the Ohm's triangle. This is optional, as this will not come in exam. This is very important. This is the base of BW, that is Ohm's law. Thank you. Now, we will start with the voltage divider rule and the current divider rule. This is basically a derived property. It is not a theorem or something, but it is very helpful in many problems. If you know it, then no problem. You can solve at least the 10 to 20% of difficulty problems by just applying this and visualizing the circuit according to this. Now, I'll just draw it. If I apply potential difference V total across this series combination of two resistances R1 and R2, and if I want the value of the voltage available across R2, then my direct formula for this is the voltage seen across R2 is equal to VR2 is equal to V total into R2 divided by R1 plus R2. That is V total R2 divided by R1 plus R2. Similarly, that is, if you want to find across R2, then multiply by R2 divided by total resistance. If you want to find voltage across, this is VR1, suppose. Voltage across R1 is VR1. Now, if I want to find VR1, so my VR1 is equal to V total into R1 divided by R1 plus R2. This is my value of VR1, voltage across seen across R1. That is my VR1. This is basically my voltage divider rule. Now, what is my current divider rule? Here, total current flowing will be same. Across each resistor will be same because there is no other branch. So current going from here will come from here only. Simple. Now, we will see the current divider rule. What is this CDR? Sometimes most famously known as CDR, and this is VDR. Now, if two resistances that are connected in parallel, R1, R2, suppose I total current is flowing, coming, as suppose V total is this voltage over here, and here the resistances are in parallel. So here some amount of current is like a water flow, as you know, that if current 100 molecules are going from here, then some molecules will go from this road and some will be going from this road. Similarly, here also this is broken into two parts, I1 and I2 only, and where I total is equal to I1 plus I2. Now, what is happening over here is I want to find the value of I2 or I1. Suppose I want to find the value of I2, and direct formula where I am knowing I total, and direct formula for this is I2 is equal to I total into opposite resistor, that is R1 divided by R1 plus R2, and direct formula for I1 is equal to I total into R2 divided by R1 plus R2. This is for I1, I will take multiply by R2. As here I used to multiply by the next resistor, but here I will not multiply by the next resistor. I will multiply here. If I wanted to find across R2, then I have had to multiply with R2. But now here, if I want to find voltage of current across R1, then I will multiply by R2. I will multiply with the opposite resistor. This is what is known as current divider rule and voltage divider rule. That's it.